Last period, we have studied application of these determinants, that is the Cramer's rule, to solve the simultaneous equations in two variables. Now today we will see Cramer's rule to solve simultaneous equations in three variables, three unknowns. So we understood this method. So consider system of equations suppose a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z equal to d3. Now d is equal to, you find the determinant d, that is the determinant of coefficients a1 b1 c1, a2 b2 c2, a3 b3 c3. Now we will evaluate this determinant as we have evaluated the determinant of order 3. Now we find dx is equal to determinant. So when we find dx, you replace coefficients of x by constant, that is first column by the constants. So we will get here d1 d2 d3, b1 b2 b3, c1 c2 c3. dy is equal to, we get determinant. Now when we will find dy, we replace second column, that is coefficients of y by constants in d. So a1 a2 a3. Now here we will replace, so d1 d2 d3, c1 c2 c3. And dz is equal to determinant. Now to find dz, you replace third column, that is coefficients of z by the constants in d. So we will get a1 b1 d1, a2 b2 d2, a3 b3 d3. So evaluate as usual the determinants of order 3, and then we will use Cramer's rule. So by Cramer's rule, x is equal to, get dx upon d, y is equal to dy upon d, z is equal to dz upon d. So by using this method, Cramer's rule, like this, we can solve simultaneous equations in three variables. Well understood. We will apply this Cramer's rule for three variables, three unknowns with example. The voltages in an electric circuit are related by following equations. Equations. So suppose V1 plus V2 plus V3 is equal to 9. V1 minus V2 plus V3 is equal to 3. V1 plus V2 minus V3 is equal to 1. Find V1, V2 and V3. So, okay, solution. Given system of equations V1 plus V2 plus V3 is equal to 9. V1 minus V2 plus V3 is equal to 3. V1 plus V2 minus V3 is equal to 1. Name this equation first, second, third. Okay, now we find D, determinant of coefficient. So 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. Now we will evaluate by the method to evaluate the determinant of order 3. So 1 into, now directly we will write, so 1 into this determinant, so that step we can reduce in applications. So minus minus plus 1 minus 1, minus 1 into minus 1 minus 1 plus 1 into 1 into 1 1 minus minus plus 1. We keep this. When we take this element, you take the determinant of this minus this element into determinant of these elements plus 1 into determinant of these elements, and directly apply this. So that is equal to, no, 1 minus 1 is a 0, minus 2 minus minus plus 2 plus 2, so that is equal to 4. Dx equal to determinant. So when we find dx means here we write dv1, v1, v2, v3 variables. So dv1 is equal to, replace first column by the constant. So 9, 3, 1, 1 minus 1, 1. So as we are replacing, you write the column wise. So 1, 1 and minus 1. So that is equal to 9 into minus minus plus 1 minus 1 minus 1 into minus 3 minus 1 plus 1 into 3 minus minus plus 1, so that is equal to 1 minus 1 will get 0. 1, this 9 into determinant this, so we will evaluate the determinant by 2 by 2 method. So minus minus plus 1 and this minus 1, minus 1 into 3 into minus 1 is a minus 3, and 1 into 1, 1 minus 1 plus 1 into 3 minus minus plus 1, like this. So now 1 minus 1 is a 0, minus 3 minus 1 minus 4, minus minus plus 4, 3 plus 1 is 4, 4 into 1 is a 4, 4 plus 4 is 8. dv2 is equal to determinant. Now dv2, its second column is replaced. So 1, 1, 1. Now this is replaced. So 9, 3, 1, 1, 1 minus 1. So that is equal to 1 into 3 to minus 1 is a minus 3 minus 1 minus 9 into minus 1 minus 1 plus 1 into 1 minus 3. So that is equal to, now minus 3 minus 1 minus 4 minus 4 into 1 minus 4 minus 4 minus 2 and minus 9 minus minus plus 18. 1 minus 3 minus 2, so 18, and this minus 6, so 12. dv3 is equal to determinant. Now third column is replaced in D. So 1, 1, 1, 1 minus 1, 1, 1, no, so 9, 3 and 1. So that is equal to, so 1 into minus 1 minus 3 minus 1 into 1 1 minus 3 plus 9 into 1 into 1 1 minus minus plus 1, so that is equal to minus 1 minus 3, so we will get minus 4. 1 minus 3, so minus 2, minus minus, we will get here plus 2. 1 plus 1, 2, 2 into 9, 18, so plus 18, so that is equal to 18 plus 2, 20, 20 minus 4 is a 60. So by Cramar's rule, x equal to d or b1 is equal to dv1 upon d, so that is equal to 8 divided by 4, so 2. b2 is equal to dv2 upon d, so that is equal to 12 upon 4, 3. v3 is equal to dv3 divided by d, so that is equal to 16 upon 4, so 4. So therefore solution is v1 is equal to 2, v2 is equal to 3, v3 equal to 4. So this is the method, that is, in this way we will apply the Cramar's rule to solve the simultaneous equations in 3 variables. We will take one more example. Second example, solve by Cramar's rule. X plus y plus z is minus 6 equal to 0. 2x plus y minus 2z plus 2 equal to 0. X plus y minus 3z plus 6 equal to 0. Solution. Given system of equations, now you take the equations in the standard form. Take the equations in standard form. So that is variables is on the left and constant on the right. So x plus y plus z is equal to, we can write 6. 2x plus y minus 2z is equal to minus 2. X plus y minus 3z is equal to minus 6. First, second and third equation. Now we find determinants. So d is equal to determinant 1 1 1, 2 1 minus 2, 1 1 minus 3. Now you evaluate this determinant of order 3. So 1 into this determinant. So this determinant, so 1 into minus 3 is a minus 3, minus minus plus 2, minus 1 into, now determinant of this and first and third column elements. So 2 into minus 3 is a minus 6, minus minus plus 2, plus 1 into 2 minus 1. So that is equal to minus 3 plus 2 minus 1. Minus 1 into 1 is a minus 1. Minus 6 plus 2 minus 4, minus minus plus 4. 2 into minus 1 is a 1. So plus 1. So 4. Dx equal to determinant. Now when we find dx, replace first column by the constant. 6 minus 2 minus 6, 1 1 1, 1 minus 2 minus 3. So that is equal to, so 6 minus 3 minus minus plus 2 minus 1 into minus minus plus 6 minus minus plus and again formula minus, so minus 6 into 2 is a 12 plus 1 into, now this element means this determinant, so minus 2 minus minus plus 6, so that is equal to, now minus 3 plus 2 is a minus 1 into 6 minus 6, 6 minus 12 minus 6 minus plus 6 minus 2 plus 6, so 4 into 1 is a plus 4. Now this gets cancelled, so that is equal to 4. Now we find dy, so dy is equal to determinant. Now when we find dy, we are replacing second column in d, so 1 to 1. Second is replaced, so 6 minus 2 minus 6 and 1 minus 2 minus 3. So that is equal to 1 into minus minus plus 6 minus minus plus again formula minus, so 12 minus 6 into 2 into minus 3 minus 6 and minus minus plus 2 plus 1 into minus 12 minus minus plus 2, so that is equal to, so minus 6 into 1 is a minus 6 minus 4 minus minus plus 24 minus 12 plus 2 minus 10 minus 10 into 1 minus 10, so that is equal to, now minus 16 and plus 24, so we get 8. dz equal to determinant, now third column is replaced in d, so 1 2 1 1 1 1, third is replaced by the constant, so 6 2 6 minus 2 minus 6, so that is equal to, so 1 into minus 6 minus minus plus 2 minus 1 into 2 into minus 6 minus 12 minus minus plus 2 plus 6 into 2 minus 1, so that is equal to, minus 6 plus 2 is a minus 4 into 1 is a minus 4 minus 12 plus 2 is a minus 10 minus minus plus 10, 2 minus 1 is 1, so plus 6, so that is equal to, so 12. By Cramar's rule, x is equal to dx upon d, so that is equal to 4 upon 4, so 1. Y is equal to dy upon d, so 8 upon 4, so 2. Z is equal to dz upon d, so 12 upon 4, 3. Therefore, solution is x is equal to 1, y is equal to 2, z is equal to 3. Now by putting these values in the equations, in the two equations, and if equations are satisfied, the answers are correct. So if we put in the first equation, so 1 plus 2, 3, 3 plus 3 is 6, 6 minus 6 is 0, okay. If we put in third equation, 1 plus 2, 3, 3 minus 9 minus 6 plus 6 0, so these answers are correct.